Hello and welcome back. Alright, so we're going to actually put these math formulas and concepts to practice. Okay, we're going to put them to use. Alright, because what good are they if you're learning all these concepts and you can't do anything with it other than just think about it, right? So that's exactly what we're going to do. We're going to put it to practice. Here I have an apparatus that shoots ball. Okay, ball right here, trigger right here, shoots, lands on that piece of paper, hopefully. Okay, and I've marked off on this piece of paper how far we are in centimeters. Okay, how far we are away from the actual trigger device in centimeters. Okay, so when we shoot this thing, it should land on that piece of paper, hopefully, and we'll be able to see how far we actually shot it. We're going to calculate the initial velocity of this apparatus. Okay, we're going to calculate the initial velocity of that. This object, this ball right now is sitting at 1.115 meters above the ground. Okay, and what importance is that to us? Why is that important? Well, this object is shooting straight out. Okay, it's shooting directly out. It is not shooting down. It is not shooting up. So because it's shooting straight out, if we took some other object, some other ball here, and we dropped it, it'll land. It'll take the same amount of time to land as an object shooting out and landing somewhere else. What does that mean? That means if you were to shoot a gun out and drop an object right next to it, they will both hit the ground at the same time. Okay? So we're going to actually practice that. We're going to see how long it takes for an object to fall at that height. Okay? We're going to get the average of 3 drops. Okay? So we've got a stopwatch here. We've got an object drop here. Okay? So we put it at the height and drop it. Whoops. Try that again. Sorry. So we put it at the height and we drop it. 34 milliseconds. $44 milliseconds. Slow on that one. 54 milliseconds. Now that is my reaction time as well, incorporated in that. So 4 plus 4 plus 4, that is 12. 3 plus 4 plus 4, 3 plus 1, 4, 5, 6, 7, 8. 8 plus 5 is 13. 132 divided by 3, 4, 12, 1, 2, 4, 44 milliseconds on average. 44 milliseconds on average. Okay? We'll see what that is here in just a minute. Now, right now, I'm going to actually shoot this thing and find out the distance. Okay? Here we go. 3, 2, 1. Okay. And we're going to see where we actually landed. We're going to see where it landed. This is carbon paper, so it leaves a mark on the bottom side. There it is. So we landed roughly at 387 centimeters. 387 centimeters is what we will write down for our distance. 387 centimeters. What is that? That is 3.87 meters. Okay? So, we have We have two formulas to work with. We're going to use this one to calculate our time, okay? Height is equal to 1/2 AT squared, okay? But we need time, okay? We need to set that equal to time, okay? So what we do is we multiply both sides by 2 to get rid of the fraction 1/2. We do 2 times h is equal to AT squared. That gets rid of the 1/2 on the right. Divide both sides by acceleration, and we have t squared is equal to 2h divided by a. Okay? Take the square root of both sides, and we just have t is equal to the square root of 2h over a. Okay? So now we have numbers for everything. We got numbers for our height. We have numbers for our acceleration. Okay? So let's put them into the formula we just found out. Right there. Okay? So let's see. We do that, we get 0.477 milliseconds. It would take, where I said 44 milliseconds, it is actually 0.477 milliseconds. That was my reaction time, I guess. Anyways, so now we have everything to calculate the initial velocity. This initial velocity of these objects, of these apparatuses, are generally 6 or 7 meters per second. We'll find out how accurate that is. So, we have our distance, 3.87, and we have our time, 0.477. And that's equal to, I can't actually do that off the top of my head. We have a calculator, and I say 3.87 divided by 0.477 is equal to 8.12. 8.12 meters per second. Okay? Kind of close. Not really. All right, so that's that. That's our formulas put to actual practice. Hope you stay tuned. Hope this has been an enjoyable demonstration for you, and they will continue to get improved as we continue this lesson. Anyway, thank you very much, and have a good day.